Hi and welcome. Now we've reached class 16 for our IB Mathematics Standard Level course. I hope you're enjoying your time till now. Now we'll start with probability distributions. So probability is a big topic, an important topic, honestly. Probability distributions, in this class we'll talk about the normal distribution and we'll talk about the binomial distribution. So for the normal distribution, we refer for the probability of having the event X is to be normally distributed with the mean, and we care about the standard deviation, but we write it as a variance here. This is for any variable X. What does normal distribution say? Let's draw a line. Normal distribution says if we have a big enough sample, we'll find that our values are normally distributed this way, having the mode, the mean, and the median at the center. And this is the shape of how the data is distributed away from the mean. So for the normal distribution, we care about the mean and the standard deviation. We care about the mean and the standard deviation. So if we want to discuss the standard deviations, we can find that within one standard deviation from the mean, we can find that 68% of our data lies here. If we go to 2 standard deviations away from the mean, this is plus, and here we go to -2 standard deviations, we can find that around 95% of my data lies within 2 standard deviations of the mean. Now to go for 3 standard deviations, this is 3 standard deviations minus 3 sigma. We can find that within 3 standard deviations, I can find nearly 99.75% of my data. Why is this important? Because my sample, I can assume that as my sample goes large, the distribution will be like this. And since the total area inside this bell curve shape, this total area here is equal to 100%, which is equal to 1. So this area represents the probability of an event to happen. So this is my normal distribution, and it's really important to know why to use it. We'll get to solve more questions as we move on within the class. Let's talk about the standardized normal distribution, or the z-score. When I want to discuss the z-score, I want to talk about the z-score is I'm talking about a standardized normal distribution. Standardized normal distribution is I'm having a z to be normally distributed for a mean to be equal to 0 and a standard deviation to be equal to 1. So this is my mean and this is my sigma squared. If we want to draw our standardized normal distribution, we have our bell curve shape. This is standardized. We'll have the mean at the 0 and the data distributed as we discussed before. It's really important to get back to the standardized value. So sometimes we have to link, because the questions, they don't usually give you the mean or the standard deviation, or they don't give you both. So you have to form two equations and get back to standardized values to be capable of solving these. So using my GDC, I go to find a probability. I go to my graphical display calculator, and let's clear this at first. I go to second distribution, and most of the time I go to normal CDF. What's meant by normal CDF? Normal CDF is normal distribution cumulative distribution function. Cumulative. Why cumulative? Because if this is, let's say this is minus 1.5, and I want to find the area here. So to find the area which represents the probability, I go to my graphical display calculator and I go to normal CDF. My GDC asks me for lower bounds and upper bounds. So here my lower bound would be a negative 1 times 10 to the power of 99, and my upper bound is minus 1.5, and my GDC directly calculates the area for me, which is the probability. If I want to go the inverse way, then I have to go to inverse norm. What's meant by the inverse norm is the inverse norm let's draw our line. The inverse norm, I'm having my distribution. This is my distribution. And let's say I'm having the mean here. And I'm having a value. No, I don't have a value, which is I keep it x. I have this area and I know this area. Let's say this area represents 15% or 0.15. So to know this x value, knowing the mean and the standard deviation, I have to go to my graphical display calculator and I have to go to inverse norm. I scroll down and I'm sorry, why I'm scrolling down. This is the third choice is the inverse norm. But be careful, your GDC always takes the area to be to the left hand side or less than x, not greater than x. If we have an area greater than x, then we have to do a 1 minus for the normal distribution. This is really important to know. The last thing we have to know before going and practicing some question is how to standardize value. To standardize value, I have the z-score is equal to the x, which is my value, minus my mean over my standard deviation. This equation is really important, as we'll use it much, because in questions they just don't get directly and they don't ask direct question in the IB. So we need to standardize to get probabilities, get back, find my next value, get back finding my mean, my standard deviation, and to solve my question. This is for the normal distribution. I hope I explained enough for this, because now I'm going to the binomial, then we'll solve questions. Now, the reason why I don't want to solve the question directly on the normal distribution, because when you get a question, you must be capable of distinguishing if this distribution is a normal distribution or is a binomial distribution, or sometimes the IB integrate the questions together. So we need to know the concept, we need to see our question, and we have to extinguish between if I need to use the normal distribution or my binomial distribution. So for the binomial distribution, I write it in the form x is binomially distributed for n trials with p, which is the probability of success. Let's explain more. B represents as a binomial distribution. N is the number of trials. And P is the probability of success. What does it mean, the probability of success? Let's say I'm having, I want to pick a ball out of 100 balls. I'm having 100 balls, and I want to pick a white ball. Knowing that from the 100 balls, I have 40 white and 60 to be red. Only two options. Is either white or red. I can't have a third option. That's why I call it a binomial distribution, because it's from the bi word, which I'm having two options only. So the probability of success here is picking out either one of the 40 balls out of 100. So here my probability of success is a 40 times, I'm sorry, it's not a time, is 40 over 100, which is 0.4. Okay, if this is my probability of success, then I must have a probability of failure. So it's either a failure or a success. I want to pick a white ball. So either I succeed or I fail. If I pick a red ball, then I fail. What's the probability of failure? I write it as Q. I write it as Q, so my probability of failure here is 60 over 100, which is 0.6. And you can see that the 0.4 and the 0.6 add up to 1. So simply P is the probability of success. So 1 minus P is equal to Q. This is my probability of failure. This is really important. Now we can continue with finding the expected values, which is the mean, and finding the variance of binomial distribution. So find the expected value of x, which is the mean. If we take our example of 40 white balls out of 100, what do you expect? How many? Which you multiply simply the probability times the number of balls. So the expected value is equal to n times P, which is in our case, N is the number of trials, which is 100, times the probability, which is 0.4. So I get 40 white balls. To find the variance of X, I need to multiply N, which is the number of trials, times P, which is the probability of success, times Q, which is the probability of failure. To write it again, which is N times P times Q, which is 1 minus P. And we can treat also the binomial distribution as the binomial expansion. But in our case, in your exams, most of the binomial distribution questions and the normal distribution questions come in paper 2. So you have your graphical display calculator. You don't have to worry about finding probabilities or the inverse norm and so on. Let's see some questions now. Have this example. This question is also from the question bank. Now, the heights of adult males in a country are normally distributed with the mean 180 and standard deviation sigma. When you find such a question, always start by drawing. You have to draw. You have to draw what's happening and what's going on in our question. So, let's draw our bell curve shape. Here on my shape, what do I have? I have the mean to be 180 centimeters. This is in centimeters. And what else do I have? I have sigma. I don't know sigma. So X is normally distributed for the mean, which is 180, and sigma squared. I don't know my standard deviation yet. So what does the question tell me? That, to continue with, 17% of these men are shorter than 168 centimeters. 17% are shorter than 168 centimeters. If I want to illustrate this on my drawing, this is the 168, and this area is 17%, which is 0.17. Is this given enough to make me calculate the unknown standard deviation? Of course it's enough. How can I calculate my sigma? I have, as I told you, to go to z-scores. Or another name is I have to standardize. Why? Because if I have my z-score, I can find my sigma, because z is equal to x minus mu over sigma. I need to find z so I can find sigma. Now, if I want to find the z value for this area, which is 0.175, it's already is given to the left. I'm having the area, but I need the z value. I'm having the probability and I need the z value. For my GDC, I go to distributions and inverse norm. So I go second, distribution. I go second, distribution, and the third choice, which is inverse norm. I press enter. So for your GDC, you'll have a clearer screen, but we have to start by the area to the left. What's my area to the left? Is 0.17. I have, this is 0.17. Then I need to plug in the mean, which is, since here I want a standardized score, or z-score, my mean is a 0, and my standard deviation is 1. And I simply close the bracket. So my z-score now is minus 0.954. My z-score is minus 0.9. This is minus 0.954. This is my DC score. Is equal to. Do I know my x? Yes, my x is 168. Minus. Do I know the mean? Yes, is 180. Over sigma. Now I'm having an equation with one unknown, which is sigma. Now I can find sigma. So simply sigma is equal to 168 minus 180 over the minus 0.954, which is equal to, go to our GDC, just we quit this window or we clear it. So I have 168 minus, this is delete, this is a minus 180, and then I divide by minus 0.954. Let's find our value. So my standard deviation is 12.6. I can take it as 12.6, or I can take extra digit, which is 12.58. So we can take it to 3SF. It doesn't matter. So we take our standard deviation to be 12.6. So my sigma is 12.6. Now, do I know my sigma? Yes, of course I do, which is 12.6. I can continue with the rest of my question. Let's continue with, is given that, okay. Now is given that 80% of them having a heights between 192 minus h. Now let's see a bit of our sketch. Let's draw this line. And remember, our shape is symmetrical. So my mean is 180. And I have the area less than 168 to be 17%. I need to find now the area which is greater than 192. Here 192. Is it symmetrical? Yes, it's symmetrical. Why? Because the difference between 180 and 168 is the same as the difference between 180 and 192. So this area is 17%. So the area to the left of the 192, the whole of this red area, is a 1 minus 17%, which is 83%. But I don't want this area. I want to find the value of h. Let's continue. Another drawing. Let's do another drawing so you can understand. This is the 192. It's 180. Now, the area between the 192 and the 192 minus h is equal to 80%. This is 80%. So the left area beneath the 192 minus h is 3%. This value can get me to know the value of h by using the inverse norm. Now, let's go to our graphical display calculator. We go to second distribution again. We go to env norm. We have the area to be 0.03. Do I know my mean? Yes, is 180. Do I know my standard deviation? Yes, I found it, which is 12.6. Close, and I get my value, which is 156.3. So now this value, which is 192 minus x minus h, is 156.3. Now I can find the value of h. So now I have 192 minus h is equal to 156.3, having h to be equal to 192 minus the answer, which is equal to 35.7. X is equal to 35.7 centimeters. This is my value of h. This was a long question, but a nice one. Let's go to solve another question. By now, it's binomial. Let's see. In a large university, the probability that student is left-handed is 0.08, which is the probability of success. A sample of 150 students is randomly selected from the university, so n is the number of trials. Let k be the expected number. Find k. Okay, it's easy. So the expected number, k, is equal n times p, which is equal to 0.08 times the 15 times the 150. I'm sorry. Now I have 0.08 times the 150, which is equal to 12. So now k is equal to 12. I know my k. Part B. Hence, find the probability that exactly k students are left-handed. So I want the probability that x is equal to k, which is x is equal to 12. I want exact 12. When I want exactly 12, I go to my GDC, I go second distribution, I go down. I have two options, either binomially, probability distribution function PDF, or a CDF. When I want the exact 12, I go to PDF. So when I go to PDF, I press enter. Okay. What's the number of trials I have is 150. What's the probability of success is 0.08. And the x value I'm having is 12. So I find the probability simply by pressing an enter, which is 0.119. So probability of x is equal to 12 is 0.119. Let's go to part C. I'm sorry, this is B, section I. And let's go to part B, section I. Hence, find the probability that fewer than k students are left-handed. Fewer than k, which I want that probability of x to be less than 12. When I want the probability to be less than 12, it means I want all the probabilities below 12. So this is equal to the probability of x less than or equal to 11. I need to write it this way so my GDC can understand, because the GDC will take the 12. So I need the probabilities of x to be a 0, 1, 2, 3, and reaching the 11. I don't want the 12. So I write it in this form. To find the probability of x is less than or equal to 11, also I go to my GDC. But this time I go to second distribution, I go to binomial CDF, which is a cumulative distribution function, because I want all the probabilities from 0 to 11 and I press and enter, then the number of trials are 150. The probability of success is 0.08, and I'm having this 11 here. I press enter, so my probability is 0.57. So my probability less than 12 is 0.457. So this is my final answer. As a reminder, at the end of each class, please keep practicing, practicing, and practicing.